Hi guys. Okay, so I'm having some like super issues with uploading the files I've done, so I'm just going to redo them now on here. So I'm redoing them live. We've got differentiation, which we'll do. I'll try do both the differentiations and the integration ones. We'll see how far we get this evening. It's quite late. And I will leave them uploading, and hopefully the other videos will upload to YouTube. So this is the set one or the test one on the differentiation from Edexcel. So we've got the curve C has an equation, y equals 3x to the 4 minus 8x cubed minus 3, and we're going to differentiate. So to start with, we're going to simply differentiate first. So the 4 comes down, 3 times 4 is going to give you 12x, take 1 away from the power, cubed, minus 24x squared. And d squared y dx squared, we're going to differentiate again. So 12 times 3 gives you 36x squared minus 48x. Says to verify. So when you see the word verify, you don't actually have to make dy dx equal to 0 and solve, you just have to substitute it in. So you're going to say when x equals 2, dy dx equals 12 times 2 cubed minus 24 times 2 squared, which equals 0. And if it doesn't equal 0, you've done something wrong and you need to go back and double check your differentiation. Determine the nature of the stationary point. To determine the nature, we're going to substitute it into d squared y dx squared. So when x equals 2, d squared y dx squared equals 36 times 2 squared minus 48 times 2. And when I plug that all in, I get 48, which is greater than 0, which tells me it's a minimum. So if it was less than 0, it's a maximum. If the second differential equals 0, it's a point of inflection. Okay, so let's have a look at the next question. So if I clear this. Right, given theta is measured in radians, prove from first principles that d theta equals cos theta equals minus sine theta. Now, I'm not going to go through this one. This is a standard proof. It's in all your textbooks. You should be able to do this. We'll do it maybe later in a video around first principles, but for the purposes of these questions, it's a very standard proof, and it's one that you can learn and follow through. Okay, so question 3. All right, so this is very similar to the first question. We've got to differentiate twice and then determine the nature. So first of all, before I start, I'm going to rewrite this equation in indice form. So when I do that, I get y equals x squared minus 2x minus 24, and it's root x, that's x to the power of a half. So now I can differentiate it. I bring the 2 down, I get 2x minus, that's 1, so it's just 2. A half times minus 24 is going to give me minus 12. A half take away 1 is minus a half. And then I'm going to differentiate it again, leaving me with 2 minus 12 times minus a half. So minus and a minus is going to make a plus, 6x to the minus 3 over 2. Verify that C has a stationary point when x equals 4, exactly like we did before. So when x equals 4, dy dx equals 2 times 4 minus 2 minus 12 times 4 to the minus a half equals 0. And then it says determine the nature. So when x equals 4, and you're just going to plug it into your calculator, d squared y dx squared equals 2 plus 6 times 4 to the power of minus 3 over 2. And that gives me 2.75, which is greater than 0. So we've got another minimum. therefore, and those 3 dots will be therefore minimum. Okay, let's go to the next question. So, okay, so now we've got one with trig. So whenever you're differentiating your trig functions, I always draw it as like a circle, and it helps. Well, I think it helps because then you can think about integration in the opposite way. So you've got sine, which differentiates to cos, which differentiates to minus sine, which differentiates to minus cos, which differentiates to sine. And if you were to go round the circle in the opposite direction, you would be integrating. Okay, so we've got something divided by something, which means we're going to use the quotient rule. And this is the one given to you in your formula books. You don't even need to learn it, but it's given to you as f and gx. We're going to use u and v just because I think it's easier to see. So we've got u equals 3 sine theta. We've got v equals 2 sine theta plus 2 cos theta. So u dash, so differentiating u, sine goes to cos. So we're going to get 3 cos theta. Differentiating v, sine goes to cos, and cos goes to minus sine. And then using the rule, your quotient rule formula, you're going to have v dash times u. So we get 3 sine theta, so dy dx, equals 3 sine theta. So you're going to that way round first. 3 sine theta, oh, sorry, done it the wrong way around. Excuse me, I was about to use the product rule. Quotient rule is VU dash. So we're going to multiply those two and then minus multiplying those two over V squared. So we're going to get 3 cos theta multiplied by 2 sine theta plus 2 cos theta minus 3 sine theta, 2 cos theta minus 2 sine theta. And the formula is all over V squared. So 2 sine theta plus 2 cos theta all squared. Okay, so let's expand the top because we want it to look like that over there. All right, so when we expand it, we get 6 cos theta sine theta plus 6 cos squared theta minus 6 cos theta sine theta plus 6 sine squared theta. So we've got, is that right? Plus, yeah. So we get 6 cos theta minus 6 cos theta. So these two cancel each other out on the top. And then if we were to take 6 outside the bracket, you'll have cos squared plus sine squared, which will leave you just with 6 on the top. So, on the bottom, we're going to get 4 sine squared theta, so square of the first, multiply them together and double it, so that become 8 sine theta cos theta plus 4 cos squared theta. So cleaning that up, apologies, I'm going to have to write it up here. We've got on the top, we've got 6 open brackets cos squared theta plus sine squared theta. On the bottom, we've got 4 sine squared theta plus cos squared theta plus 8 sine theta cos theta. Now we know cos squared plus sine squared, we know all of this, all of this equals 1, and all of this equals 1. And we also know, so this is what you definitely should know, and watch back at the trig video for all the trig equations you should know. We know that sine 2 theta is 2 sine theta cos theta. But we've got 8 sine theta cos theta. So 4 sine 2 theta will equal 8 because I've times both sides by 4. So now let's replace that all. So we'll get 6 on the top. On the bottom, we get 4 plus 4 sine 2 theta. We want to end up with 1 plus sine 2 theta. So we're going to take 4 outside of the bracket, 1 plus sine 2 theta. We've got 6 on the top. We bring that 4 to the top, and we end up with 6 over 4, which is just 3 over 2, 1 plus sine 2 theta. So in this case, your A equals 3 over 2. Right, that's a bit messy, but I hope that makes sense. So using the quotient rule, and then you're using your trig identities. Right, let's make it a bit smaller so I leave myself a bit more space this time. Okay, so again, we've got something divided by something, so we're going to use the quotient rule again. So we take the top, and that becomes our u. So u equals 5x squared plus 10x, and v equals x plus 1 all squared. We're going to differentiate this, 10x plus 10, so bring it down. We're going to differentiate this, we can bring the 2 down, take away 1, which is just 1, differentiate the bracket, which is just 1, so we just get 2x plus 1, and we know v squared is going to be x plus 1 to the power of 4. So now let's use the formula. So we've got v u dash, so multiplying those two together. And as I do that, actually let's just leave it as it is. It's going to factorize out the 10. Yeah, I can probably take the 10 out of there and make that x plus 1. Not sure if it's going to help yet. And then multiply those and maybe take the 5x out of there, and I get x plus 2. Yeah, multiplied by 2x plus 1 all over x plus 1 to the 4. So the first thing I see that I'm able to do is I can cancel out an x plus 1 from everything. So we can get rid of that there, that one there, and that's going to become cubed. So now if we open that out, on the top, we're going to end up with 10x plus 1 squared minus 10x x plus 2 over x plus 1 cubed, which gives me 10x squared plus 2x plus 1 minus 10x squared minus 20x over x plus 1 cubed. And if I just take the top, this is going to give me, so if I just open out this top bit, I've got 10x squared plus 20x plus 10 minus 10x squared minus 20x. This cancels with that, this cancels with that, and I'm left with 10 on the top. So I can see my final answer is just 10 on the top, and on the bottom, I've got x plus 1 cubed. And then it says, hence deduce the values for which dy dx is less than 0. Now, how does dy dx become less than 0? Well, we've got 10 on the top, which is a positive number. So it means, when does this bottom bit become less than 0? So it's cubed. So it's cubed. So that means whenever the bracket is negative, it's going to be less than 0. To make the bracket 0, x would have to be minus 1. So therefore, anything less than minus 1 is going to make that denominator negative, which will make the whole of dy dx negative. Okay, so I hope that makes sense. It happens with the positives. If it was squared, you obviously, it would never be negative. Okay, right. Find first by taking logarithms, the x coordinate, the turning point. Okay, so what we're going to do is we're going to do 6a here, because, and leave the iteration bit and just do the differentiation bit to start with. So it's telling you how it wants you to do it. It's telling you it wants you to take logs. So even if you know what the differential of x to the power of x is, you still are going to take logs, because that's how they want you to do it. So if I've got y equals x to the power of x, I'm going to log both sides. When I do that, I get ln y equals x ln x. And now I'm going to differentiate. Now remember, whenever you differentiate implicitly, so there's a y there, the minute you see the y, you write dy dx. So you differentiate ln y as expected, so you get 1 over y, but because there was a y, you write dy dx. And then for x ln x, we can use the product rule. So we're going to say u equals x, v equals ln x, u dash equals 1, v dash equals 1 over x, and we're going to just multiply the diagonals. So x times 1 over x is simply going to be 1 plus ln x. So then we end up with dy dx equals y times, because I multiply that up, 1 plus ln x. However, y, we know, is the same as x to the x. Next, 1 plus ln x. Okay, so we want to know when this becomes 0. So if dy dx equals 0, then the x to the x cancels, and we're left with 1 plus ln x equals 0. So ln x equals minus 1. So x equals, the opposite of ln is e to the minus 1, and that's your x coordinate. And that's the differentiation section on here. For the iteration, you're literally just substituting in numbers. So hopefully that's not too bad. Right, let's go to the next one. Right, show that f dash x. Okay, so we're going to use the product rule. I would actually combine the 4 with the 2e to the minus 2x. I think it'll just be easier. It's up to you how you write it out, but they're written sort of on other sides of the bracket just to make it look prettier. There's no good reason for that. So you could have your u would be 4e to the minus 2x, and your v is x squared minus 2. And so now we're going to differentiate them. So u dash is minus 8 e to the minus 2x, because you bring the minus 2 down, but the e never changes. And v dash equals 2x. And so therefore, f dash x is multiplying the diagonals. So we get 2x multiplied by 4e to the minus 2x plus minus e to the minus 2x multiplied by x squared minus 2. Now, if I look at the answer, we can see they've taken out 8e to the minus 2x. So 2 times 4 is 8e to the minus 2x. And inside that bracket, we're going to get x. And here we're going to get minus x squared. And we've got minus and minus, so plus 2, which is your solution. You could separate it out at the last line to make it look exactly the same. But that's what you'll do there. Then we're going to find the exact coordinates of the stationary points. So the stationary points happen when f dash x equals 0. So we're going to make all of this equal to 0. When we do that, well, we know if that's impossible to equal 0, because our E graph never equals 0. So it does not equal 0 anywhere. So we're not going to worry about that. So then we're going to take the bracket minus x squared and make that equal to 0. You're either going to sub it into your calculator or factorize it quickly, and you'll get x is minus 1 or 2. And then to get, because it says coordinates, you've got to sub them back in to get your y values. So f of minus 1 will be 4 minus 1 squared, which is 1, minus 2, which is minus 1, e to the minus 2 times minus 1, which is 2. So your y coordinate that goes with minus 1 is just going to be minus 4e squared. And f of 2 is 4, 2 squared, which is 4, minus 2, which is 2. E to the minus 2 times 2, which is just going to give you minus 4 as well. So you're going to get 8 e to the minus 4. So your final answer will be your stationary points are -1, -4e squared, and 2, 8e to the -4. And because it asks for coordinates, you need your x and you need your y values. Okay. Next question. Oh, doesn't want to scroll. Okay. We've got a bowl, water belongs to flow into the bowl. At time t, after the water begins to flow, the height of the bowl is h. The volume is modeled as. So whenever you do questions like this, let's just increase it so you can see what we're talking about. Let's just do the first bit. All right, I think there's a typo. Well, that should just be centimeters cubed. Okay, so water flows into the bowl at a constant rate. Whenever you do any exam questions and you see the word rate, your brain is going to go dt, because rate is how something changes with time. So what's changing with time? We're going to look at the units, which is centimeters cubed, so that's volume. So we know dv dt is equal to 80 pi. Okay. We are asked, and so this is just me reading the question. So now let's have a look. Show according to the model, it takes 36 seconds to fill the bowl from empty to a height of 24. So if we think about it, we know that the volume divided by the time, the rate it takes, will give us the number of seconds. So your time is effectively going to be, you're going to plug in 24, because that's your height, into your volume. So V equals 4 pi 24 multiplied by 24 plus 6. And that gives you, so that gives me 2880 pi. So that's the volume at 24 centimeters cubed. Now we know that every second 80 pi is coming out, because that's the rate it's coming out. So if we do 2880 pi divided by 80 pi, these cancel. You could just say t equals, you plug that into your calculator and you see it takes 36 seconds. So that's the easy bit. That's the one marker, but you still have to think about it a bit. So now find, according to the model, the rate of change of the height. So if I clear that, let's scroll up. So let's re-put that in where we had dv dt equals 80 pi. So we want the rate, so we see the word rate again, we want dt, but we want the rate of the height. So we want to end up with dh dt. Okay, so we want dh dt. We know that from this bit here, v equals, we could open out those brackets, 4 pi h squared plus 24 pi h. So we know dv dt. We can work out dv dh by differentiating this. So that's going to give you, remember pi is just a constant, you treat it as a number. So that's just going to give you 4 times 2, 8 pi h plus 24 pi. And then you can say, well, I want dh dt, so I want the h on the top. In order to do that, I have to flip over dh dv. I want to move this onto the top. So this is going to end up on the, I'm flipping it over. So I'm getting 1 over 8 pi h plus 24 pi. And I'm multiplying that. So what I've effectively done, actually, maybe write it down here. dh dt will be dh dv, because I want the h on the top, multiplied by dv dt. Because if you notice, I have to cancel those, I end up with dh dt. So I'm multiplying that by 80 pi. Okay, so I've still got a h in there. I've got nowhere to put the t equals 8 in. but now I've got an expression for dh dt. So now what I need to do is say when t equals 8, what is h? So when t equals 8, I know I can work out what the volume is. So when t equals 8, the volume equals, so we know when t equals 8, it's being full 80 pi every second, but there's 8 seconds. So I get the volume is going to be 640 pi. So then what I can do is I can say 640 pi equals all of this. So 640 pi equals 4 pi h plus 6. The pi's cancel. I'm going to open that out and I'm going to get, I could do 640 divided by 4, which gives me 160, get rid of that, equals h squared plus 6h. Move it all onto one side, h squared plus 6h minus 160 equals 0. Plug that into my calculator, I get minus 16, which makes no sense, and h equals 10. But because I've already done all the work for DHD, that's why it's 8 marks, by the way, it's a lot of work, I'm going to plug this h equals 10 into my DHDT, and I'm going to get 1 over, well, the pi's can all cancel, 1 over 8 times 10, so 80 plus 24, so 1 over 80, yeah, 88 times 2 is 80 plus 24, so 104, 80 plus 24, so 104 on the bottom, times 80, which gives me 0.7, is one exact? No. So 0.769 centimeters per second. All right, so I hope that makes sense. I've gone through step by step, but it's 8 marks, so you kind of expect it to be quite a bit of work. Okay, next one. Okay. Figure 5 shows a curve. Okay, so we're going to use the quotient rule again, because we've got 2 things divided by each other. So you've got u equals 4 sine 2x, and v equals e to the root 2, it's just the root 2 that's, yeah, minus 1. So u dash, remember when you differentiate, sine differentiates to cos, but if you've got a number here, that's got to be multiplied in the front. So you get 8 cos 2x. Here, you differentiate the power and bring it in front. So the differential of the power is just going to give you root 2, e to the root 2x minus 1. And then we're going to do multiply these 2 together minus multiplying these 2 together over v squared. So when we do that, and because we're not asked to prettify it and it's just show the x coordinates, don't try simplify it or do anything fancy with it, just stick it in the formula to start with. So f dash x is going to be e root 2x minus 1 times by 8 cos 2x minus root 2e root 2x minus 1 multiplied by 4 sine 2x all over v squared, which was e root 2x minus 1 all squared. Now, because we're finding the minimum points, we're actually making all of this equal to 0. And when we make it equal to 0, that's going to multiply up and disappear. And then we're left with e root 2x minus 1 times 8 cos 2x minus root 2e root 2x minus 1 times 4 sine 2x equals 0. We can divide through by the e's, and they disappear, and we're left with 8 cos 2x, I'm going to move the other bit to the other side, equaling 4 root 2 sine 2x. Now I know I want tan. Tan is the same as sine over cos. So I'm going to divide the cos onto that side. And we'll divide the numbers onto that side. And when I do that, I get sine over cos is tan 2x. And then I'm going to have 8 divided by 4 sine over cos, and I've got 8 over 4, which is 2. So I've got 8 over 4 root 2. Let's do it like that. And when I cancel that, that gives me 2 over root 2. So it's going to be 2 over root 2. But I want it to show it as root 2. Now, all you have to do that is 2 over root 2. If you rationalize the denominator, you end up with 2 root 2 over 2, which cancels and is the same as root 2. So I think if you wrote that just as the next step, it would have been sufficient to get the marks. Okay. I remember this question. Okay, so I remember marking this question, and it wasn't done particularly well. Just people got themselves in a massive muddle. But as long as you do the differentiation right, the actual marks for rearranging part B is not that much. But let's go through the process. Okay, so the first bit, nice and easy. The population at the start of the study, if t equals 0, anything to the power of 0 is always 1. So you end up with 900 over 3 plus 7. You've got 900 over 3 plus 7, which is 10. So you end up with 90. That's nice and easy. Now we're going to differentiate it. Now this is not the quotient rule. You don't have a function at the top and on the bottom. You can simply rewrite this as 900 3 plus 7e to the minus 0.25t to the power of minus 1. You don't need to. You're not dividing one thing by the other. This is not the quotient rule, okay? So dn dt, you bring the minus 1 down. So we get minus 900, 3 plus 7e to the minus 0.25t to the minus 2 multiplied by the differential of the bracket. And I am purposely writing it how I'm writing it right now, and it will make more sense in a bit. Okay. So now I'm left with, hopefully I've got enough space, maybe very small, dn dt equals minus 900 over, because minus 2 is on the denominator, 7e minus 0.25t all squared, multiplied by 7 times minus 0.25 e to the minus 0.25t. Okay, what I want to now do is put that all in terms of n. So I'm going to look at what I have, and I'm going to try rearrange different bits of it. So if I take a look at this, and I rearrange it for this bit here, and I can see that 3 plus 7e to the minus 0.25t is the same as 900 over n. It's because you remember with fractions, you can just swap them. Okay, so we've got that. We also know that if we want, okay, if we start with that, we can, obviously that's what we can substitute in over here. But we look at our answers and we also see we don't have any e to the 0.5t, but we can do this together and we'll get 7e to the 0.5t. So 7e to the 0.25 rather t is the same as 900 over n minus 3. So now I can just substitute it all in. So I end up with minus 900 divided by 900 over n squared. So that's substituting all of this, substituting that in. So we can sort that out in a second. Multiplied by, and I can put the 7 with the e to the minus 0.25. So if we leave the minus 0.25 outside, and 7e to the minus 0.25, which we said was 900 over n minus 3. Okay. We know when we divide by a fraction, it's the same by multiplying it and flipping it. So we get n squared over 900 multiplied by, I'm going to make that minus a quarter, multiplied by 900 over n. And we also have, sorry, that should have been a plus sign there, apologies. Oh, no, it's a multiply, ignore me. Oh, and then we've got minus 3 times by minus 0.25. So we got 3/4 there as well. Actually, sorry, as you can tell, I'm doing this late at night. What we're going to do is actually simplify. We're going to make this into one fraction because it's going to come out easier. So we get minus a quarter, and then we're going to make all of that over n and do 900 minus 3n. Okay, so now if we have a look, this is 900 squared. That cancels with that, and we get left with minus n squared on the top there. We've got 900 divided by 4. Where have I gone wrong? 900 over n minus 3. So over, oh God. All right, so we've got a minus and a minus, so that becomes a plus. That becomes a plus there. That becomes over 4. And then that's going to be 900 minus 3n over n. And 900 times 4, sorry, I lost that 900. So 900 times 4 gives us 3,600. So n squared over 3,600, 900 minus 3n over n. That cancels with that. And then we end up with the answer. So if you have a look, you can divide through by 3, and that will become 300, and that will become n. So we're left with n, 300 minus n, exactly as we have there, over 1,200. Okay, apologies if that was a little bit of a mess, but essentially, when you do this, most of your marks, so 3 out of your 4 marks, are for the differentiation and substituting something in. So the rest, which gets a little bit messy, actually isn't worth more than a mark. Okay, the rate of growth is a maximum after t months. Find, according to the model, the value of t. Now, it's going to be a maximum after, is a maximum after t months. Okay, so we said 900 divided by, rate of growth is given by, so n is 300, and we want to find the maximum for t. Okay, so the maximum is given when dn, the rate of growth is a maximum of t months, when dn dt equals 0, which we can see is either n equals 0 or n equals 300. So if n equals 300, we can then substitute that into the n there, and we can solve it to find our value. So we get 300 equals 900 over 3 plus 7e to the minus 0.25t, which leaves us with 3 plus 7e to the minus 0.25t equals 900 divided by 300, which gives you 3. Wait, that's going to give me 0. Subject by the start of the equation. Find the number of mice in the population at the start. Show that the rate of growth is the maximum after t months. Oh, apologies. Sorry, not being very smart here. This is going to be 150, which will make a lot more sense. So we've got 150, and let's make that 150 because it's going to be half the amount. So we're going to get 7e to the minus 0.25t equals, and so 900 divided by 150 is 6. So 6 minus 3 is going to be 3. E to the minus 0.25t equals 3/7. Okay, this makes a lot more sense. And then e to the minus 0.25t equals ln of 3/7. And then if you divide by minus a quarter, it's the same as multiplying minus 4. So t equals minus 4 ln of 3/7. You plug that into your calculator and you get 3.4 months. God, I hope that makes sense. Right, according to the model, the maximum number of mice on the island is P. Now that's what I actually answered first in part C without thinking. So not the maximum rate, but the maximum amount of mice. So the maximum amount of mice, you can tell what that is by looking at here, and you say as t gets bigger and bigger and bigger, e to the minus 0.5t goes towards 0, and then you're left with 900 over 3, which is 300. So the maximum value will be just less than 300. It'll never actually reach 300. So the maximum value will actually be 299. But I think they would have given you the mark for 300. Okay, so for your maximum rate of growth, that's when you're making your differential equal to 0, and you could so that's not the maximum rate of growth, that's the differential again equaling to 0. So I hope that makes sense. So if you think of the curve, it's a quadratic, so 150 will be smack bang in the middle, and that's when this graph is at its maximum. So between 0 and 300, you've got 150. So that's where the 150 comes from. Hope I haven't confused anyone too much. Right, let's have a look at the last question. Oh, there's more than 2 last questions. The one before last question. Right, the curve C is in standard Cartesian plane. Find the value of dy dx at the origin. So because we're given x equals, what we've actually got to do is dx dy instead of dy dx. So dx dy is going to give us, the 2 gets multiplied there, 8, sine differentiates to cos 2y. Therefore, dy dx is going to be 1 over 8 cos 2y. And we want to know it at the origin. At the origin, y equals 0. So dy dx, cos of 0 we know is 1. So dy dx is simply 1/8. Then part B, use small angle approximation for sine 2y to find an equation linking x and y for close to the origin. Okay, so in your formula book, it tells you sine theta is approximately theta. So sine 2y is just approximately 2y when y is small. So if we replace that with 2y, we get x equals 8y. So y equals 1 over 8x. So your relationship is the value found in A and the value found in B part 1 is the gradient of the line. Gradient of line. And now we've got to show that. Now this comes up a lot. So here you've got to use your trig identities to rearrange that differential. So even though school may have said to you, oh, it's a differentiation test, remember you still need all of this other stuff. Okay, so first thing to do is to make sine 2y the subject of the formula. So sine 2y is the same as x over 4. And then I'm going to say to myself, what's the connection between sine 2y and cos 2y? Well, I know that sine squared plus cos squared equals 1. So cos squared must be 1 minus sine squared. So cos 2y must be the square root of 1 minus sine squared 2y, which is the square root of 1 minus x squared over 16, right? Which is the same as, if I make that fraction 16 on the bottom, that's going to be 16 minus x squared. So I'm like, okay, so dy dx is the same as 1 over 8 square root 16 minus x squared over 16, which is the same as 1 over 8 square root 16 minus x squared. The square root of 16 is 4, so over 4, that cancels and gives you 2, and now yours looks like this. So you've got 1 over 2 root 16 minus x squared. Okay, hope that makes sense. So you're just looking at your trig identities. They become so important. You need to learn that list. Okay, next one. Oh, last one. Okay, so we have tan equals x squared equals tan y equals 9. Show that. Okay, so we've got another one with trig and another one. This is actually implicit, but also the product rule. So what do we have here? We've got u equals, so we'll have u equals x squared, v equals tan y, u dash will be 2x, v dash will be sec squared y, but because it's a y, we have to write dy dx. Right, so now we're going to cross and multiply. So we get x squared sec squared y dy dx plus 2x tan y, and then 9 just differentiates to 0. We want to make, so now if we notice there's no secs or tans inside this answer, so before we rearrange it, it's easier to sub stuff in. So again, we take this and we rearrange it. We know that tan y is going to be 9 over x squared. We know our trig identity, so we know 1 who is tanned is sexy. Oh, 6, we're doing y, so let's put y. So we know that 1 plus 81 over x to the 4 is sec squared y, which is what we want to replace that with. So now let's replace it. So x squared multiplied by 1 plus 81 over x to the 4 dy dx plus 2x multiplied by 9 over x squared equals 0. If we open this out, we get x squared plus 81 over x squared dy dx. This is going to cancel with that, plus 18 over x equals 0. I'm going to make that into one fraction, put x to the 4 on the bottom, and I'm going to get x to the 4, sorry, x squared on the bottom, x to the 4 plus 81. dy dx equals, and if I move it onto the other side, minus 18 over x. And then I want to divide by all of that, which is the same as multiplying by minus 18 over x multiplied by x squared over x4 plus 81. That cancels with that, and I'm left with the answer. All right, part B, prove that C has a point of inflection at x equals the 4th root of 27. So remember, a point of inflection is when the second differential equals 0. And then either before and after, the sign changes. But the main marks here are for differentiating again. So we're going to use the quotient rule. So if I get rid of all of that. And we're going to say u equals minus 18x, v equals x to the 4 plus 81, u dash equals minus 18, v dash equals 4x cubed. We're going to multiply and minus this time. So we get minus 18, x to the 4 plus 81, minus, so it's going to be plus 18x 4x cubed over v squared. All right, if we clean out the top, we end up with minus 18x to the 4. Then we've got 18 times 4 minus 18. So we end up with 54x to the 4 minus 20 minus, let's reword, 81 times minus 18, which gives us minus 1458. Yeah, okay, over x to the 4 plus 81 squared. If we now make that, so that's my d squared y dx squared, if we make that equal to 0, we'll end up with 54x to the 4 minus 1458 equals 0. So x to the 4 equals 27. So x equals the 4th root of 27. And then you also have to show that with a point of inflection, you're going to say, well, when x is less than, so you just pick something slightly below it, d squared y dx squared, by subbing in your numbers into there, is less than 0. When it equals the 4th root, d squared y dx squared, we've just proved equals 0. And when it's greater than the 4th root, you get d squared y dx squared is greater than 0. Therefore, it is a point of inflection. Okay, so hopefully that wasn't too disastrous. I'll look at the other differentiation topics and put them as a separate bit. And like I said, as soon as the cleaner versions decide to upload, you'll get those, but hopefully this you can work through these. Leave me any messages. It's easier to like annoy me on Instagram, but I will get back to anybody in the next couple of days if you've got any questions. And also, if you have a look at zahraclassroom.com, actually, let's see if I can put it up here so you can see. Excuse the state of me. So, okay. So if you guys go to zahraclassroom.com, if you go to maths, and if you have a look in A-level, under Edexcel, some of my previous students, there's some work solutions up there, and we'll be putting up as many as we can within the next few days. So hopefully those are useful as well. Good luck to everyone taking exams, and if there is anything I can help with, I will try, although technology hasn't really been my friend the last few days.